Hey guys, so today we are going to start talking some more about transformations of graphs. So basically, the nice thing about today is I'm not going to make this well, it will be a play pause it, but it will not be a play pause it where you have to answer questions. So this is basically just a notes video about transformations. Okay, so no questions or anything like that. But you do need to watch the video so you can fill out your notes. Okay, you should have already printed out the blank page of notes. Okay, if you haven't already done that, you might want to stop now and go back and print out the blank page, and we'll go from there. Okay, there are a couple of things that we're going to change based upon what is already written. Okay, so you've been given a function y equals f of x. Okay. It could be that's just some sort of function. You could have like f of x equals x squared. Okay, that's one of your parent functions that we talked about the other day. You could have f of x equals the absolute value of x. Again, that's another parent function that we talked about. We also talked about both vertical and horizontal shifts the other day. Okay, so vertical shifts basically that is affecting the y value. Okay, so for example, a vertical shift upward, and you guys already know this, y equals f of x plus k. That is a vertical shift. Now this says C. Now your notes say C. Please replace that C with a K. You are more familiar with HK form than you would be with C. So let's go ahead and put where it says vertical shift C units upward in your notes, change that to a K. Now a vertical shift K units downward. Well, you guys should already know this. Okay, this would be y equals f of x minus k. And I think that kind of makes sense to you. Okay, so I'm not going to spend a lot of time with that. Now, horizontal shifts. A horizontal shift, what will it affect? Okay, so horizontal shifts, they affect the x value. All right, and again, instead of having c units, we're going to replace the c with what you're more familiar with, and we're going to call it h. So horizontal shift h units to the right would be y equals f of x minus h. And remember, this is to the right. Okay, and that's number 3 in your notes. Then number 4 on the front of your notes, y equals f of x plus h. Again, replacing this c on the where it says c units to the left with the h. This means that you're shifting it to the left. And what we did in class on Friday was try to give you a feel for that. No matter what parent function you had, the horizontal and vertical shifts are exactly the same in anything. Okay. A third type of transformation that we want to talk about is a reflection. Okay, a reflection about the x-axis, basically flipping it over the x-axis, is the same idea. Some of you actually remembered on Friday that if there is a negative value in front, so if you have a negative f of x, that is what flips over the x-axis. Okay. What about the y-axis then? Well, this one's a little bit harder to describe. Okay. This case, you actually have the negative in the function, so it's f, not just f of x, but it's f of negative x. Okay. So to give you an example with our x squared, y equals negative x squared. That flips it over from this, okay, to this. Okay. Now, y equals negative x squared. Interestingly enough, dealing with this function, this is what it looks like normally. You know, this is the origin, this is the function. If you put in y equals negative x, guess what happens, guys? It actually, if it flips over the y-axis, it's going to look exactly the same, isn't it? Okay. This tells us this is something called an even function, and we'll talk about even and odd functions in the near future. Okay. Well, if I'm putting a negative on the outside flips it over the x-axis, and putting a negative on the inside flips it over the y-axis, what's the other type of reflection that we have? Okay. Now, when I say flip, I mean a reflection, but in this case, it's a kind of a reflection, a double reflection. So our last type, a reflection about the origin, would be y equals negative f of negative x. Okay. So that would be a full 180 degree rotation around the origin. And that kind of makes sense, because if I do negative x, what happens? It flips over the y-axis. It looks exactly the same. And then if I do negative of negative x, well, it already looks exactly the same, and then flipping it over the x-axis just turns it upside down. So this is where it ends up, and that is a 180 degree rotation as well about the origin. Now, not all of them work out so nicely. All three of those types of transformations, vertical shifts, horizontal shifts, and reflections, they are all rigid transformations. So vertical shifts, horizontal shifts, and reflections are all rigid transformations. That means that the size and shape of the object does not change. Okay? The size, it's a horrible S, I know, and shape of the object doesn't change. Now, there are also transformations. Again, this is a lot of geometry, okay, and a little bit of algebra too, that I'm throwing in here, okay. So there are also transformations that are non-rigid, okay. So we have non-rigid transformations. And with non-rigid transformations, as it kind of sounds, there is a distortion, okay, of the figure. It does not keep its size or shape. It will either stretch, in which case that is a vertical expansion, or it will shrink, and that is a contraction. Actually, let me change something here. I'm not going to say vertical expansion. Okay, I'm just going to say right now that a stretch is just an expansion. Okay, and a shrink is exactly what it sounds like. It's a contraction. Okay, So there are things that we can do to functions that will make the function either stretch or shrink. Okay. Now these get a little bit more complicated, so I'm going to slow down a little bit and try and walk through these a little bit easier. Okay, so let's take a look at number 8. In this case, we can now actually leave the letters as C because you are familiar with them. So with number 8, we have y equals some constant C, some number, times f of x. Okay. Notice it's on the outside of the function. Okay, the C is on the outside of the function. Okay, so this affects the y value. All right. So now what happens? What about C? Okay. If C is greater than 1, which you have on your notes, C greater than 1, we have a vertical stretch. Okay. I don't have one of those neat pens to write on with my iPad, so I'm using a stylus, and the stylus is kind of like messy, and I already have messy handwriting, so just to let you know, I'm trying to get it a little bit better, but it's going to be a bit. Okay. Now, what if I have 0 is less than C, which is less than 1? Well, then we have a vertical shrink. Okay. Now, what if C is less than 0? Well, then that becomes negative, and now all of a sudden we have a reflection. Okay. So C in this case will never be anything less than 0. If it is any fraction of between 0 and 1, we're going to be shrinking our function. If it is any whole number, or if it's any number greater than 1, it's going to be stretching it. And what if it's 1? Well, if it's 1, then that's like, the same size. All right, we're not shrinking it or stretching it. Now, number 9, notice where C is. We have y equals f of cx. In this case, the C is inside, and this is going to affect the x value. Okay. And just like everything else with the x value, anything that's on the inside of the function is exactly backwards than what you would say. So if C is greater than 1, instead of it being a stretch, it is a shrink, and in this case it is a horizontal because it affects the x value. Shrink. Okay. And then likewise, if we have 0 is less than C, which is less than 1, we are going to horizontally stretch. Okay. Okay. Let's do an example. Okay. So I'm going to give you a function. I'm going to write that function down. Y equals f of x. And the domain of this function is 1 to 5 inclusive. And the range of this function is going to be from -3 to 6. Okay. Now let's say that we do something to this function. Let's say we do this. Y equals f of x minus 4 plus 7. Okay. So what are we doing? We are moving this function to the right 4 and up 7. Okay. So what's our new domain going to be? Well, if I move it to the right 4, the 1 becomes a 5. What does the 5 become? That becomes 9, right? What does our range do? Well, I started at -3 and I moved it up 7, so that becomes 4. And here, if I started at 6 and moved 7, it becomes 13. Okay. Hopefully that makes sense. Remember, what did we have? We had a right 2. I'm sorry, a right 4 and an up 7. Okay. Okay, to finish off, we're going to finish up with the absolute value. So for number 10, this is the second page of the notes, you have a function y equals the absolute value of the f of x. Well, let's think about this, what happens. Okay, so we plug in some values, we get, f of x equals whatever it equals. But if we take the absolute value of that particular answer, that's going to eliminate all of our negative answers. Okay, so basically what happens here is this reflects all negative y values above the x-axis. Let's do an example here. Y equals x cubed. Okay, the graph of that looks something like this. Okay, here's my x and y, comes up, goes up like that. But if I take y equals the absolute value of x cubed, what happens to my graph? What will that look like? Well, instead of coming down here, it's going to come up front, up top. So basically, it's going to all of a sudden turn into almost like a quadratic. Okay? So that's what the absolute value on the outside of f of x does. All right. Let's take a look at what number 11 does on our notes. We have y equals f of the absolute value of x. So in this case, what happens? Instead of taking all of our y's and taking whatever negative y we had, it now becomes positive. Now what happens? Now all of our negative x's, okay, anything to the left of the negative x, creates a mirror. It's going to create a mirror image. Okay, so this erases all negative x values, and the graph becomes a mirror. So let's say we had some function that did this. Okay, here's my normal function. Comes down, comes up, y equals f of x. Now, all of these negative values, everything that's on this side, are going to actually end up becoming a mirror of everything that's on the right side. So the right side is going to stay the same. It's still going to go kind of like this. But instead of doing this up and down thing, this is going to become a mirror, because basically all you're doing is you're taking all these negative x values and saying, okay, well, now they're positive, and then what was the answer for the positive? So we can still get a negative value for the function, but we can't get, but it's going to look exactly like what's on the positive side. So basically it mirrors across the y-axis this time. Okay. So I know that you've seen everything else in geometry, but I know that the absolute value was a little bit more of a, hey, maybe you haven't seen that before, and it's okay. It's just taking another step, but now you have an idea of what happens here when we're dealing with absolute value. So let's take a look at our examples. Okay. Example number 1, it says f of x equals x cubed, and it says describe the transformation. Well, in 1a, let's try this again. F of x equals x cubed. So in A, we have g of x equals x cubed minus 1. Okay, guys, outside the function, on nothing in front of it or anything like that, usually behind it. It can be in front, but usually it's behind. This one's straightforward. This should be just, every one of you should realize that this is just a down 1, and that's the only transformation. Okay? Now let's deal a little bit with h of x. H of x has a little bit more to it. We have a negative. We have x plus 2, and it should be cubed, guys, plus 4. Okay? So there's lots going on here. First, we're going to include this plus 4. That means that since it's plus, we're going up 4. Okay, we have this plus 2 inside. Okay, so that plus 2 inside means we're going left 2. And then we have this negative out front. Since it's not inside the function, it's on the outside. That means it's reflecting. It's reflecting over which axis? The x-axis. Okay, and when you're trying to do, when you're trying to solve these, order of operations, okay. If you're trying to graph, a function and what the next function would be, you would do the first you would do the left 2, okay. Then you can reflect. Sorry about that, guys. As I was saying, when you're doing these, do the order of operations first. You're going to go left 2 first, then you're going to reflect it over the x-axis, and then you will move it up 4. Please do not move it up 4 and then reflect it. It does make a bit of a difference. Okay, so please, order of operations, inside the function first, then the reflection, and then up or down. Okay? All right, now part C, you have j of x equals 5 times the quantity 2x cubed minus 7. Okay, lots of things going on here. One thing that we don't have is we don't have any horizontal movement, left or right. Okay, but we do have some dilation, some vertical expansions, and things like that. So outside, we have a vertical stretch. And it's a stretch because this number is greater than 1, and it's actually by a factor of 5. Again, if I'm just asking you to identify the transformations, you don't have to tell me in an order of how they would happen, but you do need to know the order of how they would happen. The 2x, this 2 is on the inside of the function, it's multiplied by the x. So that is a horizontal shrink by a factor of 2. So in other words, you're shrinking it in half. Okay? And then last but not least, we have down 7. Okay? So that's number 1 on your examples. Let's go through number 2. Number 2 says f of x equals the square root of x. Okay, now we're going to do a little bit different. Now I'm going to give you something to, I'm going to give you what the transformations are, and you have to give me the equation. Okay? Well, we have reflected over the y-axis. Okay, so that means we're on the inside here. So to start off with, the reflection over the y-axis gives me f of x equals the square root of negative x. Remember, if it was over the x-axis, it'd be on the outside. Okay. Now we have a vertical shrink by a factor of 5. So the vertical shrink happens outside of the function. So we have f of x. Now if it's a shrink by a factor of 5, that means it is 1/5 how big it was. So it's the square root of negative x. Okay? And then last, down 3. Well, that should be pretty straightforward. Down 3 would be f of x equals 1/5 the square root of negative x minus 3. Okay? Hope so. Okay. Now for part B, we're going to start back over with our square root of x. Okay? So we have reflected over the x-axis this time. So now f of x is simply negative square root of x. See the difference? Horizontal stretch by a factor of 4. Okay, so that means we're inside the function, and we're not multiplying by 4x. Okay, we're multiplying by 1/4 x. Okay, because again, if in order for it to be a stretch, it has to be a between 0 and 1. Okay, and then last but not least, we have up 6. Well, that should be pretty straightforward. F of x equals negative square root of 1/4x, and if we're going up 6, we're going outside the function, plus 6. Okay, last one. Okay, we have, again, f of x equals the square root of x. Now we have the horizontal shrink by a factor of 2 and shifted left 3 units. So here's our horizontal shrink. By a factor of 2 would give me y equals the square root of, or f of x equals the square root of 2x. Okay, again, horizontal inside the function. Okay, and now we have a shifted left of 3 units. Well, that's going to give me, again, I keep switching between f of x and y. The square root of 2. Now remember, what gets shifted is the x plus 3, so I'd have to put that in parentheses, so that, and then the 2 would actually affect that as well. Okay? Guys, if you have any questions, I will be available from 12:30 to 3:30 today. And then of course I will see you tomorrow morning. You do have a homework assignment, so make sure you work on that homework assignment. Thanks, and have a great day.